Hey guys.
Hello.
So this week we're going to be talking about an electronics project we just finished. The folks at CNS Summit asked us if we could design them an electronic badge for their conference this year.
Yep. CNS Summit is a conference which gathers individuals from all sorts of clinical research groups, pharmaceutical groups, just to talk about the latest innovations and medical technology for patients.
And considering that this was a medical themed conference, during our brainstorming, we came up with the idea of doing a double helix strand of DNA where each of the bases and the base pairs were lights. And you can see the artwork here is very reminiscent of how DNA is shown. And on each one, there's a light there. And in its initial state, when you first power up the badge, the lights are sort of floating around from color to color. And it isn't until you go out and find a person to plug your badge into their badge that a base will lock into a set color based off the unique ID in their badge. And you have to find 16 unique people at the conference to fully unlock all of your DNA, or lock it in, as it were. And that unlocks new animation sequences to occur.
Hi there. I'm Addie from Addie Tech.
Hello, Addie. I am Whisker from Whisker Tech.
Hi, Whisker. What can I do for you?
I don't know. Do you think that we should work together with our medical technology devices?
Are we compatible?
I don't know, but it looks like we can find out with our nifty conference badges. It looks like both of us have unlocked DNA on each other's badges, which means we're compatible.
Awesome. See you later.
I was thinking it would be rather smart to plug our badges into each other a second time to avoid having to talk to other conference attendees.
That's rather tricky, Whisker.
We should try it.
We should.
Oh no, our badges has detected our subterfuge.
I guess we can't do it that way.
We're going to have to go be social.
See you later.
All right, so now that we're done with our excellent acting, both these badges have wandered around the conference and they are fully unlocked. So let's check out the animations. There's a power switch on the back. All right, so you can see now that these badges are not just blinking random colors. They've unlocked all of their sequences, and the sequence is animating down. And it's rolling back around to the top and animating down, animating down.
The lights.
And here's where things get interesting. If we plug these two fully unlocked badges into one another, the animation sequence will no longer be down. My DNA will get pushed into this badge, wrap around, and it will push the DNA into this badge. So we can actually move DNA from badge to badge if we're careful about when we plug them in and when we disconnect them. We all lined up?
I think so.
All right, so now if we look carefully here, pick a color to watch, and you'll see that it actually goes in a ring here, because the DNA colors are actually being pushed out one badge into the other. And if you're looking for a particular color to collect, you just wait till it's on your badge and then, hey, that's mine. And that'll stay on this, and when you turn this off and on again, it'll load back up and it'll still have that color that you're trying to steal.
Collaborate.
Oh, yeah, collaborate.
Right.
So Addie's going to talk about some of the design elements here and the process of using this cool FR4, etc. And I'm going to show you guys some good, nice high-res photos of these so you can see all the cool trace work and all that we did.
So the neat thing about this badge is that it's on black FR4 as opposed to the stereotypical beige tan. And instead of your stereotypical green solder mask, we actually have clear solder mask on the black FR4. And what that does is it allows us to use the copper underneath it as artwork.
You can normally use the copper as artwork, but only by, say, flooding an area in copper and then cutting a hole into the solder mask so that you can see through a solder mask at just that point, and you can see through it in the shape of the artwork that you're trying to put on the board. But in this case, the copper itself is in the shape of the artwork, and you can see through all of the solder mask because it is clear.
Right.
So you can see along the edge of the board there, I put in copper hexagons and pentagons. Those are the same as the molecular, molecule structures that you often see with the different letters in DNA.
Right, like A, C, T, and G.
And you can see that the copper traces go right through them, and it's like, those are the molecular bonds the electrons are dancing around on. And over the top where the lights are shining across, we have the situation where in some ways when they try to show what DNA is, they'll do it in a banded pattern. And I'm not a biologist, so I don't know exactly what those are or how to read them, but they look cool, so I put them on the badge too. One of my favorite parts on this one is how I use the copper layer to do the molecule behind the CNS Summit text, and then the silk screen layer to superimpose the text of their conference name over the top of that. So I was able to get both the logos that they requested into that same area on the PCB, which helped keep the PCB looking, really light and really narrow, and I didn't have to have these big empty areas to handle both those things. On the back, you can see that we hid all of the processor stuff underneath the battery pack. So everything that you see on the back is stuff that, normal conference attendees would not think was all that strange. It looks circuity, but,
it's not
doesn't
overwhelming.
have a big chip on the back of it, right?
And this badge just happens to be propeller based.
Yeah,
So-
there's a propeller on there. So
Yep.
8 core, I'm running it at 40 megahertz. And using pretty much all 8 cores to handle the Charlie plexing and the graphics engine and the light driver and all that sort of stuff on the front. And as previously on badges that we've designed, there are nice big cutouts in the middle of the badge, which makes it interesting to route the traces around, but it makes for a really nice visual impact when somebody sees the badge. Normal people aren't used to seeing PCBs that they can hold in their hand, let alone PCBs that have artistic holes routed out of the middle of them. And we definitely designed our traces on this so that you can follow them, and they're interesting to look at. And they're nice and organically shaped and curved, and some of that is to avoid electrical problems with fast signals bouncing around and echoing back off of corners, but a lot of it is just visual. Most of these lines are fairly slow. The Charlie plexing isn't running super fast, so the circuit shouldn't be too noisy. The RGBs are interesting because they're side firing surface mount. They shoot over the tops of those striped patterns, and I think the effect looks really good once you get them in a lower light situation. They really illuminate off to the side, and the fact that they're RGB LEDs means they can be pretty much any color, and I went with a there's 2 bits per color per LED, so it's essentially 6-bit color, which was fun to write a graphics engine for.
Yeah, so that's our CNS Summit 2016 badge. We hope you enjoyed taking a look at what it does, what we got it to do, and if you happen to have one, I hope you were able to get all 16 lights unlocked and that you were able to get it at least to the cascading effect.
And if you're technically adept, there are Easter eggs on the serial port down there at the bottom of the badge. So, poke the right bits in there and you'll get interesting stuff out of your badge. That's it for us. See you guys next time.
See ya.
Bye.
We post videos all the time, so don't forget to subscribe. And follow us on Twitter at TYMKRS.